Good day, everyone. On this beautiful Thursday, we thank God for this greatest opportunity which He have granted us to meet once more again. Everyone. On this beautiful Thursday, we thank God for this greatest opportunity which He have granted us. Do you hear me? Do you hear me? Please, if you hear me, please type something on the comment section. Please, if you hear me, please type on the comment section. Please, I kindly ask you so that I can be notified. Okay, let's start today's tutorial. Okay, let's just wait for 2 minutes so that maybe 2 or 4 people also join us. Let's just wait a little bit, then we can start our tutorial for today. Awesome. Let's get the ball rolling. Today we'll be doing calculus. It's approximately question 7 to question 10, if I'm not mistaken. So welcome everyone. If you are new to this channel, please don't forget to subscribe. Don't forget to hit the bell so that you can be notified always when we are live. Going down to what we're going to be doing today, we'll be doing calculus. We'll be doing calculus today. It's a beautiful, nice topic which is so important, which we all have to know, with something which is so essential, which carries a lot of marks. calculus. So on calculus today, I'm just gonna look at two things, just giving you an overview of what is important under this topic. So firstly, the thing which is important firstly is we have to know that we have the first principles. We'll be derivating by using the first principles. And the first principle says that f derivative of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. That's the first principle. So whenever they say solve, or when they say determine the first derivative, when it's only one, it's called the first derivative of x. Using the first principles, you use this equation in this format, that f prime, or the first derivative of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Then now, this is the long way. This is sort of like the long division, but choosing the short one when they just say determine, or they just say derive the following, we know that we have what we call the power rule. So on the power rule, for instance, they will say determine, maybe you are given f of x to be equal to x to the power n. So if they say determine the first derivative, or f prime of x, the power rule says that it will be the exponent multiplied by the coefficient of x. So in this case, it's going to be n x, then you subtract 1 from the exponent. So that's the power rule. That's so important also. Then now the annotations that we have to know, that for instance that f prime of x is the same as d over dx. We also have dy over dx, and we also have dx. This all means the same thing. It all means the first derivative. Okay, so these notations are all the same. They have the same meaning. They are all representing the first derivative. Then if maybe, let me just do an example quickly, a small example. If maybe you are given that y is equal to 3x squared, what is the derivative? The derivative of y equal to 3x squared, you have to write dy over dx. We are differentiating y through x, so it's gonna be, we say that this is a power rule, so it's gonna be 3 times 2, and 3 times 2 is 6, then x, then 2 minus 1, then we are left with 1. So the derivative will be 6x. Maybe let me just do number 1. Number 2, if we are given f of x, which is equal to 2x cubed, if they ask the derivative of that, we know that the derivative will be f prime of x, because they gave you f of x. In this instance, they gave you y, so you are supposed to write dy over dx. So now they gave you f of x, so the first derivative, or the f prime of x, will be written in this format. Then we know that by the power rule, 3 times 2 is equivalent to 6. Then x, then we subtract the exponent 3 minus 1, then we are left with 2. Then you are able to solve your equation. Then when, for instance, they give you dx 6x4, then when you're differentiating this one, you don't have to, they'll give you, just like in this format, you just have to go and derive and have your answer. What is the derivation? It's always going to be 6 times 4, and 6 times 4 is equivalent to 24. So it's equivalent to 24. Since it is equivalent to 24, you write it 24 x, then 4 minus 1, you have 3. Then you are done. You just have to write like this if they give you in this format. So this is what is important when we are looking on the overview. Now moving forward, now we have what we call the functions under calculus. We have functions under calculus. So the functions under calculus, they are in this kind of way. Okay. Mine is ugly. I know yours will be beautiful. Then the other one must be a decreasing function and increasing function. They're in this format. You can see that they have these turning points. They have two turning points. So now, firstly, we know that when we were taught initially about polynomials, let me just, the third polynomial, it's in the format of f of x is equal to a x cubed plus b x squared plus cx plus d. So this is the things which we'll be dealing with. You are dealing with the polynomial 3, number 3, which is ax cubed plus bx squared plus cx plus d. We were taught on how to solve using the factor theorem, using the remainder theorem, so that you can be able to attain and simplify this. So as we all know, in order for you to plot this function, the first thing we must know is we must calculate the x and y intercept. As always, we know that for x intercept, we let y to be equal to 0, and for the y intercept, we let x to be equivalent to 0. Then the other thing is now we must calculate the turning points. These are important, and the turning point is when the graph is concaving. It can either concave down or concave up. So we have to know that for that, we know that you have to calculate f prime of x. Then we have to equate it to 0. Then if they ask you for point of inflation, this is for turning point. So you're going to get the x values. Then you're going to substitute the x values into the original equation which you have been given. Then for point of inflation, you just have to determine f prime of x, which other words, you must determine the second derivative, or the second derivative of your function. Then you equate it to equal to 0. Please don't forget that this is for point of inflation. Yes, it's point of inflection. Now, moving to the third one now, which is also important. Sometimes they say, for which values of x will the function concave down? So you just have to know that for concavity of down, the f prime of x must be less than 0. And for concaving up, the f prime of x must be greater than 0. So those are the values in which this function. So in other words, when they say for which values of f of x is the graph concaving down, we are saying that where are these 2 points which the graph is concaving down. So you also have to know that. So this was just an overview for you guys. Also know that the gradient, let me just highlight something. The gradient, we were doing analytical geometry on Tuesday. We said the gradient is y2 minus y1 over x2 minus x1. Now, having f of x, for instance, to be equal to a is x squared plus bx plus c. This is a quadratic function, or it's just a parabola, this one. So we have to know that the tangent, this is now important now, the tangent. In order for you to know the tangent, we know the parabola is in this form, but this point is called this straight line is the tangent to this specific form. So in order for you to determine the gradient of this tangent, we know that what do? We have to determine f prime of x. Then this specific point a comma b, they have values. Then after you determine the first derivative, now you have to find f of a. You substitute only the x value of the point of intersection of the tangent and the graph which you have. Then after that, you'll be able to determine the gradient. Then after that, using the original formula, which you know, y minus y1 equal to mx minus x1, where y1 and x1 is the point of intersection of both the tangent and the graph which you are given. So that's all. That's the overview which I had for you guys. Now, without wasting much time, let's hit to do question. Let's do question now. Let's do question. If you have any question, please don't forget to ask on the comment section. If you wanna ask, maybe you can also ask us in our WhatsApp group, or you can ask us on Facebook. We'll be willing to assist you. Now, let's start with the question 7 for today. Now, question 7. question 7. Please don't hesitate to ask. Calculus is the beautiful part of paper 1. Actually, paper 1 is the nicest paper ever. Everything, it revolves around x. Okay, let's start on question 7.1. They're saying given f of x is equal to 2x minus 2x squared minus x, determine f prime of x from first principles. Underline from first principles. You're not going to use the shorter method. No, you have to determine it from first principles. So how are we going to determine that from first principles? We are given f of x, which is equivalent to 2x squared minus x. So now from first principles, we know that we have to have f prime of x, which is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So we must have f of x plus h. So what do we do now? This is the formula. This is the formula for the first principles now. But we must have this one. So I always advise that do it before you substitute on the original equation. We are given f of x, which is equal to 2x squared minus x. Now we have to calculate f of x plus h, which is this one. So f of x plus h, where in other words, now it means that wherever you see x, we have to substitute by x plus h. So we're going to have 2. Then where there's x, we have to substitute by x plus h all squared minus where there is x, we put x plus h. Now let's solve it. We know that by opening bracket, you're going to have x squared plus 2hx plus h squared. You expand that bracket. I know you know that from solving for x. That's x plus h squared. You just solve it and expand the bracket and have x squared plus 2hx plus h squared. Then we subtract x minus h, because negative 1 times x is negative x and negative 1 times h is negative h. Then we proceed and we have 2 times x squared. You're going to have 2x squared plus 4hx plus 2h squared minus x minus h. So this is our f of x plus h. So now it's no longer hard. We just have to plug into the equation, which we know. So looking on our equation, we know that what we're going to do here is that we're just going to write f prime of x is equal to the limit as h approaches 0. We know that we have f of x plus h, so we substitute that, which is this one, which is 2x squared plus 4hx plus 2h squared minus x minus h minus, what is our f of x? Or f of x is open bracket. Please, open bracket is essential, because that minus sign affects everything of f of x. So we're gonna have 2x squared minus x, then you close bracket, then we all divide everything by h. Come on now, let's go and solve our question. The limit as h approaches 0 is going to be 2x squared plus 4hx plus 2h squared minus x minus h minus, then negative 1 times 2x squared, it's negative 2x squared, then negative times negative x is plus x all divided by h. Now looking for like terms, 2x squared minus 2x squared is going to be equal to 0. Negative x plus x is equal to 0. This is sweet. Now let's proceed now. So as we are going forward, we're going to have the limit as h approaches 0 to be equivalent to 4hx plus 2h squared minus h all divided by h. Look at something here. We have a common factor on the numerator. So limit as h approaches 0, then the common factor is h only, so we are left with 4x plus 2h minus 1 all divided by h, and we know that we can h and h, they can cancel each other. They can cancel each other. Sorry, they can cancel each other. Then they give us 1 and 1. Then now we are left with the limit as h approaches 0 of 4x plus 2h minus 1. Then after there, we substitute wherever we see h, we have to replace with 0 so that we can remove the limit. Then we have equal to 4x plus 2 times 0 minus 1, which is equal to 4x minus 1. So therefore, we can conclude that the first derivative of f of x is 4x minus 1. So if you solve this by the first principles, you're gonna have your 4x minus 1. Yo, it's quite long, but this is what they want when you are solving by first principles. They want you to use this long method. Please, the first thing which we did here is that we're given f of x to be equal to 2x squared minus x. So the first thing which we did here is that we started by solving f of x plus h. Then we ended up, and wherever we see x, we substituted by x plus h in the original f of x equation. Then we were able to attain, and we solved it, and we were able to have f of x plus h, which is equivalent to 2x squared plus 4hx plus 2h squared minus h minus x minus h. Then after we arrived to this step, then now we substituted to our equation. We know that our equation is that limit as h approaches 0 of f of x plus h minus f of x. Then this is our f of x plus h, which we have calculated initially. Then we subtract by f of x. This is f of x. This is f of x. Then after that, we looked at the common like terms, which is 2x squared minus 2x squared. Then it gave us 0. Then negative x plus x is also 0. Then we were left with 4hx plus 2h squared minus h. Then after that, we looked for the common factor on top on the numerator. Then we find out h is the common factor there. Then after that, we end up having 4x plus 2h minus 1. Then we substituted according to the limits. We substituted our x h equal to 0 on this part. Then after that, we ended up having 4x minus 1. Let me show you something. You can always prove your answer that are you right. We were given f of x to be equal to 2x squared minus 1. So we know that using our shorter method, the f prime of x is equal to, by power rule, 2 times 2 is 4x. Then 2 minus 1 is 1. Then minus then 1 times 1 is 1. Then 1 minus 1 is 0. So we have x to the 0, and we know that x to the 0 is equivalent to 1. So 1 times 1 it's 1. So you can see that our answer is the same. Now that's how you solve it by the first principles. Now let's move forward. Epic, please, if you have any question, do ask. If you have any question, please do ask. Great. Let's move forward now. Let's look at 7.2.1. 7.2.1. So they are saying determine dx of x plus 1 and 3x minus 7. So if they told you to determine, how do you determine that? I always advise that solve what you have inside of your bracket. So you can solve this. We know that these are just factors, so we can turn them back to be a trinomial. So by doing so, to be x times 3x, we have 3x squared. Then x times negative 7, we have negative 7x. Then 1 times 3x is positive 3x. Then 1 times negative 7 is negative 7. I'm doing this to show you how I will arrive to the answer. Dx, then it's going to be 3x squared. 3x minus 7x is negative 4x minus 7. Then after that, now we can just derive. You still remember what we said initially when I was giving you an overview. We say that on the overview, we have to understand the fact that dx, we solve dx by just after we are done having something simple, we can just determine the derivative just like that. So that's what we're going to apply here in this question. So let's determine it. So we know that 3x squared, we know that 2 times 3 it's 6x, then 2 minus 1 it's 1, minus, then we know that 1 times 4 is negative 4, then 1 minus 1 is 0. Then the derivative of a constant number, it's equal to 0, guys. So this is our answer. Let me just write it here. Let me just say NB so that you can remember. NB, the derivative of a constant number is 0. Any number, the derivative of any number is equivalent to 0. Any number, it's equivalent to 0. Always know that any number is equivalent to 0. It's equivalent. Even if it's pi, it's equivalent to 0. How can we prove that? So that maybe you can say Vian is lying. For instance, maybe we have 7 x to the power 0, because you know x to the power 0 is equal to 1. So we have 7 x to the power 0. Now let me just do this. We have 7 is the same as 7x to the power 0. So by power rule, we know that it's the exponent of x times the coefficient of x. 0 times 7 is 0. Then x minus 1. You see, we already have 0 here. So we are already done. So that's why we are saying that the constant of the derivative of a constant is equivalent to 0. Then now let's move to 7.2.2. We are given y to be equivalent to square root of x. We're given that square root of x cubed minus 5 over x plus 1 over 2 pi. Okay. Given this one, in order for us to derive this one, let's have a simplified written. Okay? So we know that's a square root. We can write that as x to the power 3 over 2. We all know that, guys. We all know that. That's how we can write it. Minus 5x to the power negative 1. Because when we transpose and take x from the denominator to the numerator, it's going to be minus 1. Then plus 1 over 2 pi. 1 over 2 pi, it's a constant, guys, because 1 over 2 pi is 3,14. So 1 over 2 times 3,14, it's a constant. So we already know that the derivative of 1 over 2 pi it's 0. Then now we want to determine the derivative. Now since we're given y, we said we're going to write in the notation of dy over dx. Then by power rule, 3 over 2 times what? It's going to be 3 over 2 x. Then 3 over 2 minus 1, it's 1 over 2. Then we come here, negative 1 times negative 5 is positive 5. Then x, then negative 1 minus 1, it's negative 2. Then a constant, we have 0. So you can leave your answer in a positive exponent. So it's going to be 3 over 2 x 1 over 2. Or you can just say this one, it's root of x plus 5 over x squared. Then you are done solving. Your question. So that's how we solve that question. You solve it in that way, that you just have to know that if they ask you, this one is not essential, but if they say leave it in the positive exponents, you just leave it in this format. That should be 3 over 2 times square root of x plus 5 over x squared. That's always the case, guys. Okay. Let's move forward. Seems like no one have any question. So moving forward, we are moving now to question 8. Let's move to question 8. Now. Okay. Question 8, it's still calculus, guys. question 8. On question 8, the question reads as, given f of x is equal to x, open bracket, x minus 3 squared with f prime of 1 equal to f prime of 3 equal to 0 and f prime of 1 equal to 4. F of 1 is equal to 4. Wow. They've given us a lot of things here. We know that when they say f prime of 1, which means that's a stationary point. We already know that. That's a stationary point, f prime of 1. Because we said f prime of x. When it's equal to 0, we are trying to determine the stationary points, the stationary coordinates. So we already know that f prime of 1, it's 0. And also know that f prime of 3 is equivalent to 0. Which means the stationary point will be on 1 is to 0 and 3 is to 0. Then you're also given that f prime of 1, f of 1 is equal to 4. Then you're also given f of x. Now, let's go to our questions now. 8.1. Show that f has a point of inflection at x is equal to 2. How do we show that the point f of x have a point of inflection? We must determine the second derivative of x. Then after that, we do the testing. So now, let's go now. We are given f of x to be equal to x, then x minus 3 all squared. Let's expand this, guys. We know that x minus 3 all squared it's gonna be x squared minus 6x then plus 9. Yes, so it's gonna be x times x squared minus 6x plus 9. When you expand this bracket, then x times this will be x cubed minus 6x squared plus 9x. So basically our f of x is x cubed. It's x cubed minus 6x squared plus 9x squared plus 9x. This is not necessary. This step is not that necessary. We were just trying to I was trying to show you that this is how we can solve. This is how we can solve. So basically f of x is x, open bracket, x minus 3 squared. So we just expanded it, expanded the brackets which we were given here. Epic. Now, this is our f of x. So we say that in order for us to determine the point of inflection, we must know the second derivative. So let's start by the first derivative. F prime of x will be equal to 3x, because 3 times 1, it's 3x. Then 3 minus 1, it's x squared. Then 2 times negative 6, it's negative 12x. Then 2 minus 1, it's 1. Then plus 1 times 9 is positive 9. So we have 3x squared minus 12x plus 9. We are not yet done. We're going to take again the second derivative. So we need f prime of x, which is equal to, now we derive this first derivative. So 2 times 3 is 6, then x, then 2 minus 1 it's 1. Then minus, then 1 times 12 is 12. Then 1 minus 1 is 0. So we have the second derivative to be 6x minus 2. Please write this small English that at point of inflection, f prime of x is equal to 0. So if it is equal to 0, so we just have to write 6x minus 12 is equal to 0. Then we can solve that 6x is equal to 12. Then divide by 6, divide by 6. Then we end up having x equal to 2. So we were able to show that f has a point of inflection at x is equivalent to 2. But we are not yet done, guys. We are not yet done. We are not yet done because we must have an explanation so that we can really prove that it has a point of inflection. So we find out it is x equal to 2. So I always urge people that we write, we have this number pattern so that we can have an explanation. Explanation always have 1 mark, okay? So here we have our 2. So this side, it's f prime of x must be less now. Then this one is f prime of x must be greater than 0. Yeah. Okay, now, so in order for us now to determine is this real, which means this side we must have when we substitute with any value which is less than 2. Let's use 0 because 0 is 2, so we have to determine f prime prime of 0, and f prime or second derivative of f will be 6 times 0 minus 12. Then we end up having negative 12. So negative 12 is less than 2. We can see that we are supporting the side. Now we have to have a number which is also greater than 2. So let's substitute f prime prime of 3 now. Was 3 plus 1, it's yes. So we have 6 times 3 minus 12. Then that will be equivalent to 18 minus 12, it's 6. So now we can now conclude that therefore point of inflection at, we have a point of inflection at x equal to 2. Let me repeat this part. Let me repeat this part, guys. Let me repeat this part. Repeating this part of explanation, we have to understand that yes, we were able to find it, but now let's prove it, and let's show that really what we have here is gonna support everything. So we write a number line. So we must determine f prime prime of x, or the second derivative of x, when it is less than and when it is greater than. So in other words, we must prove it that surely it is the point of inflection. We must have a negative 1 and a positive 1 so that it can be balanced. So that's what we did. We determined any number which is less than 2, even if we're going to place 1 here, because 2 minus 1 is 1 here. We're going to have 1, we're going to have 0 here, we're going to have 3, we are going to have 4. So if we substitute by any number which is less than 2, we're going to get a negative number here. For instance, if we placed 1 here, it's going to be negative 6. Negative 6 is less than 2. Then after that, we have to show that also after the point of inflection which we have, we must have a positive number. So if we substitute by 3, we brought 6. If we are substituting by 4, it's going to be 6 times 4, which is 24. Then 24 minus 12, it's 12. So also that's a positive number. So that's how we solve this. And when they ask you to show that it is a point of inflection, that's how you can show that surely there's a point of inflection. Surely there's a point of inflection. Now let's move forward. Let's move forward to our 8.2. 8.2. So on 8.2, sketch the graph of f, clearly indicating the intercepts with the axis and the turning points. Okay. On my word. Okay, it's better. It's better. So we are also told that f of 1 is 4. So let's have our 1 here. F of 1 is equal to 4. Where is this thing again? Let's have 0, 1, 2, 3, and 4. Okay. So by the way, we remember that we say that in order for us to plot, we must have 3 things. First thing, we must have the x-intercept. So let's just check them out so that everyone will be on board with me. We're having f of x equal to x and x minus 3 squared. Let's just write y here. Then x-intercept, we let y equal to 0. So we're going to have x, then x minus 3 all squared is equal to 0. So we know that x will be equal to 0, or x minus 3 all squared will be equal to 0. Then we're going to end up having x is equal to positive 3. So this is our x-intercept. Okay, let's determine their y. This is our x-intercept. So we have 0 is to 0 and 3 is to 0. Okay, those are our x-intercept. Please, guys, remember that always. So we have a 0 is to 0. We have 0 is to 0 here, and we have 1 is to 4. That's our turning point, guys. That's our turning point. And we also have 3 is to 0. That's also our turning point. That's also our turning. Remember that we said that f prime of 1 and f prime of 3, they are equal to 0. Which means these are our stationary points, guys. Okay, these are our stationary points. So we can also still determine them, guys. We can still determine the okay, sorry. So we say that this is we want to plot this function. How we're gonna do that? We have to determine the x-intercept first. So we solved for the x-intercept, then we solved by letting y equal to 0. Then we had x open bracket x minus 3 all squared is equivalent to 0. Then after that we said x is equal to 0 and this is equal to 0. Then solving for x, we ended up having 0 and 3. This is our x-intercept. The turning point, we said we need the f prime. So if we know that our f prime, is our f prime? Because I think we once did f prime. This is our f prime, guys. This is our f prime. So if that one is our x prime, let's just come in and say our f prime of x is equal to 3x squared minus 12x plus 9. That's our f prime. So if we equate it to 0, because at turning point f prime of x is equal to 0, so we're going to have 3x squared minus 12x plus 9 equal to 0, which is the same as x squared minus 4x plus 3 equal to 0. Then x minus 3 and x minus 1 equal to 0. So we end up having x is equal to 3 or x is equal to 1. Okay, so these are our two values for the turning point or the stationary point. So we also have to have the y values of this point. So how do we do that? We substitute these 3 into the original equation. So f of 3 will be equal to 3 times 3 minus 3 all squared, which is equivalent to 0. So we have the turning point, which is 3 is to 0. So we already know that on our function we have a turning point here. And let me just remove this one here so that we go all together with the same pace. Okay, so we started by determining the x-intercept. Then we find out the x-intercept is 0 is to 0 and 3 is to 0. Now we are determining the stationary points. How do we determine the stationary point or the turning points? We said that we have to let the f prime of x or the first derivative of x to be equivalent to 0. Then after that we solve and we got two answers, 3 and 1. Then now we need the y values of the turning point. So we substituted by 3 into the original equation. Then we ended up having 3 is to 0. Now let's substitute 1. So f of 1 is equal to 1 minus 3 all squared. 1 minus 3, guys, is 2. Then 2 squared is equal to 4. So in other words, we have 1 is to 4. These are our stationary points. So we have everything which we need now. Let's plot it so that you can see it, guys. We have 1, 2, 3, and 4. And we have 0 here. So we said that we have 2x intercept. Do you remember? We have 0 is to 0 and 3 is to 0. So we come here and say 0 is to 0. We have a point here. We also have 1, we have 2, we have 3. And at 3 is to 0, we also have an x-intercept. Then let's look at our turning point coordinates. On our turning points, we have 3 is to 0, which means here the graph has to turn. Bear in mind, this is an increasing function, guys, because it's an increasing function. Why? Because it's positive. The value of a is positive here. The value of a is positive. Let me just check here. No. Come on now. Come on. Here, we can see that it's positive because our function is 1x cubed. So since the value of a here is positive, which means this is an increasing function, guys. So let's move as we are moving. So now we have our turning point. to be 3. So it's going to be an increasing function. Eh? So we also have another turning point, which is 1:4. 1:4, which is here. So this is also a turning. So you can now plot our function. Jesus Christ. Okay. So this is our function, guys. We have 1:4 here. We have 3:0. And we have 0:0. Please, guys, if you have any question, do ask. If you have any question, please do ask. I am willing to answer you. So that will be our graph. That will be our graph. Doesn't have to have corners, guys. This marker is giving me problems. It must be something which is so nice, something like this. Something with night curve, guys. Yeah, something like this, something which is really concaving, so that you can really see that it's concaving. Okay, now let's move forward, guys. Let's move forward and do number 8.3. So on 8.3, they're saying for which values of x will f of x equal to negative f of x be concaving down? Okay, do you see something? It has been reflected. That graph, our graph has been reflected along the x-axis. So we have to look on where the graph will be able to concave up. The graphs concave up when x is greater than 2. Do you see that? From here, from this point, when x is greater than 2, it is concaving up. So it has been reflected along the x-axis, which means that's going to be our answer. Okay, now, so we just have to write that f concave up for x greater than 2. Okay, when x is greater than 2, you can see that the graph starts to concave up. It's concaving up. X greater than 2, it's concaving up. Okay, it will concave up when x is greater. Then therefore we can now say y equal to negative f of x, which is the reflection along the f of x, will concave down at x greater than 2. Let me explain this with simple English, guys. So we say that since the graph will concave, the original function before the reflection, it concaves up at when x is greater than 2. It only concaves up when x is greater than 2. Yes. When x is greater than 2, the graph starts to concave up. Okay. So after that, we also have to understand that, okay, this is the original function without any reflection. It's concaving up when x is greater than 2. So now, when it is reflected now along the x-axis, which means when the part which was concaving up, now it has to do the opposite, and it's now going to concave down because of the reflection. So since the part which was concaving up is now concaving down due to the reflection, that's now we have to understand that where x was greater than 2 on the original, after the reflection, now that part which was concaving up is now concaving down. So in order for us to have the concave down points, we just have to find first when f was concaving up. It was concaving up when x was greater than 2. Then now it's concaving down. Okay, it will concave down now when x is greater than 2 because of the reflection, guys. Because of the reflection. Now let's move to 8.4. 8.4.1. Use the 8.4.1. Use your graph to answer the following question. Determine the coordinates of the local maximum of h if h of x is f(x minus 2 plus 3). The local maximum. What is our local maximum? The local maximum is when the graph here is the local maximum, guys. Okay, that's our local maximum. That's easy. That's easy. So when they say it has been translated, it has been shifted, actually, it has been shifted 3 units up. So this is our local maximum, guys. Let me just write it. Our local maximum is 1:4. That was our local maximum of f. So now let's look now on h of x, which is equal to f(x minus 2 plus 3), which means this graph now on the local maximum, it has been shifted 2 units to the right. So we have to say 1 plus 3 because it has been shifted. So now 1 plus 2, sorry, that will give us 3. Then it has also been shifted 3 units upwards. So now it will affect the y. Now it's going to be 4 plus 3, which is equal to 7. So therefore the coordinates, which the 1 is 3 is to 7, guys. So these are the coordinates of h of x, because what they just did is it just shifted the graph 2 units to the right, which means it's going more positive. So they've shifted 2 units to the right. So in other words, guys, let me just show you that they've shifted 2 units. So it's going to be 1, 2. So it's 3. Shifted 2 units to the right. Then now also plus 3, they've shifted 3 units upwards. So 4, 5, 6, 7. So that's how that has to go. That's how that has to go, guys. That's how that has to go. That's how it's going to be. So the local maximum, it's 1:4. This is our local maximum. So the local maximum have been the x value was shifted 2 units to the right. So I showed you that this is how you shift it to the right. 1, 2. Then we ended up having 3. So now we have the x coordinate to be 3. Then on the value of y of the local maximum, it has been shifted 3 units upwards. So we just shift 3 units upwards as well. So it's going to be 3, 4, 5, 6, and 7. So those are the 3 units. Then after that, we add 4 plus 3, then we end up having 7. So this is the coordinate which they want. Let's go to 8.4.2, guys. 8.4.2. 8.4.2. Okay. Now on 8.4.2, they are saying Clara claims that f prime of 2 is equivalent to 1. Do you agree with Clara? Just fire your answer. F prime of 2 is equal to 1. Now, me, I won't agree. Well, if we can look at this question clearly, we can just do this easy thing. F prime of 2 is not equal to 1. Let's just determine f prime of 2. So f prime of 2 is equal to 3 times 2 squared minus 6 times 2 plus 9, which is equal to 3 times 4. It's 12 minus 12. 12 minus 12 minus, okay, let me just check something. Okay, here it's supposed to be 12, sorry for the typo. Okay, like this. But this is our, let me just do this first so that you don't get confused. So we have f prime of x to be equal to 3 prime 3x squared minus 12x plus 9. So let's now determine f prime of 2. F prime of 2 is 3 times 2 squared minus 12 times 2 plus 9. Then we end up having negative 3. So we can, if just like that, we can just show that this is not equivalent to negative 1. What they want us is that Clara claims that f prime of 2 is equal to 1. That's not true, because f prime of 2 is equivalent to negative 3, which means that's not true. Clara is lying. This is 2017, guys. Calculus. Let's see the total marks. The total marks was 15. 15 plus 12, that's 27. Wow, that's 27. So if you have these marks, you are done. So this is our calculus. Let's do last calculus activity. Let's do another question for 2016, so to polish ourselves up as well. Let's look at 2016 right now. Let's look at 2016. Let's look at 2016. Okay, let's look at 2016 now. Question 8. 2016. It's financial notes. Yes, question 8. Gonna do question 8 and question 9. 2016 now. Please, if you have any question, I am so willing to assist. Don't forget to type if you need an assist. Now, let's look at the question 8 so that we can just finalize this and move on to something else. Let's just finalize this and move on to something else, guys. Now, let's look at 2016. November 2016. November 2016. Okay, determine f prime of x from first principles. If f of x is equal to 3x squared. We already know, for the fact that they told us from first principles, we already know what we are supposed to do. We have to use the long division, the long method. How do we do that? Easy. We say that earlier on, we know that, let's just write question 8. Okay, we say that f 8.1. So we are given f of x to determine f prime of x. This is by first principles. It's gonna be limit as h approaches 0 of f of x plus h minus f of x all divided by h. So now let's determine f of x plus h. We are given f of x to be equal to 3x squared, and f of x plus h is equal to 3x plus h all squared, which is the same as 3 equal to 3. Then expanding that bracket is going to be x squared plus 2hx plus h squared. Then multiplying by the scalar multiplier is going to be 3x squared. 3 times x squared is 3x squared plus 3 times 2h is going to be 6hx. Then 3 times is going to be plus 3h squared. Now, let's determine by the first principles. So by the first principles, f prime of x will be equal to the limit as h approaches 0. What is our f of x plus h? It's going to be 3x squared plus 6hx plus 3h squared minus. What is our f of x? Our f of x is 3x squared. We divide everything by h. Then looking for like terms, we see that 3x squared minus 3x squared is equal to 0. Then we proceed now with our question. Don't forget to continue with the limit. You remove limit only when you are already substituting with 0. Only that is when you do that. Okay. Now, moving forward, so we're going to have the limit as h approaches 0. And what is our common factor on the top? On the top, our common factor is h, and you have 6x plus 3h. We divide everything by h. Then again, h and h will cancel each other, guys. Then after that, if they cancel each other, we will be left with equal to the limit as h approaches 0 of 6x plus 3h. Then we substitute our h equal to 0 there. So we have 6x plus 3 times 0. Then we end up having 6x only. So that is our f prime of x by the first principles. But if they didn't say first principles, we know that f of x, let me just use a different pen. If they didn't say by first principles, we know that if you are given f of x equal to 3x squared, you can solve this by power rule. The power rule says that's xn, y equal to xn, then dy over dx is equal to nxn minus 1. So that's the power rule. So we apply the power rule here. It's going to be f prime of x equal to 2 times 3, because you can see that n times, so it's 2 times 3, which is 6x, then 2 minus 1, we end up having positive 1. So we can see that f prime, if you use the shorter method by the power rule, it's still the same as the one on top. Still the same as the one on top. Okay, let's look on our question 8.2 now. Okay, on 8.2, they are saying that John determines g prime of a and the derivative of a certain function of g at x is equal to a, and arrives that at the answer that the limit as h approaches 0 of square root of h plus h minus 2 over h. Okay, write down the values of g and the value of a. How will we solve that kind of equation? How will you solve that kind of equation? That kind of equation, we'll solve it by doing this. We solve that kind of equation by doing this. We solve it by just writing that the limit of square root of 4 plus h minus 2, it's h approaches 0, all divided by h. So we can say that the g of x will be square root of x, guys. Square root of x. Then the value of a can be 4. If we say g prime of a, g prime of 4, then we'll be able to solve. So these are the two values. G of x is square root of x, and the value of a is 4. Bear in mind, guys, this part, it's f of x plus h. Don't forget that. Don't forget that. So the square root of x, then our value of a is this 4, which is that side. Now let's move forward to 8.3. 8.3, 8.3, 8.3. 8.3, they say determine dy over dx. You see, the questions, they are still the same. We are given that y is equal to square root of x cubed minus 5 over x cubed. So before we determine the derivative, let's arrange this. Let's remove the square root. So it's going to be x equal to 3 over 2 minus 5x to the power negative 3. So the denominator, we take it up to be on the numerator. Then we can solve our question right now. We can determine our dy over dx, which is equal to power rule. It's going to be 3 over 2x, then 3 over 2 minus 1, it's 1 over 2, minus negative 3, sorry. Negative 3 times negative 5 is plus 15x to the power negative 4. So that will be our answer. That will be the derivative. That will be the first derivative, or the dy over dx. Now let's look at 8.4, which is a bit challenging. At 8.4, for 5 marks, they are given, they are saying that g of x is equal to negative 8x plus 20 is a tangent to the function f of x, x cubed plus ax cubed plus bx plus 18 at x is equal to 1. Calculate the values of a and b. As I mentioned that earlier, guys, that the gradient of the tangent is equivalent to f prime, or the first derivative of x at that specific x point. I still remember when I said that if this is your graph and this is the point, this is the tangent, and the gradient of the tangent is the same. Let me just say the gradient of the tangent is the same as f prime of x. Let me just say a here. If here it's a is to be the x value of the point, the x value of the point, as I said earlier, the x value of the point, it's equivalent. So the gradient of the tangent is equivalent to f prime of a. So this one we have to solve it simultaneously, understanding what we have. So firstly, we are given f of x, which is equal to x cubed plus a x squared plus bx plus 18. So since it's plus 18 now, let's determine our f prime of x, because we are told about the tangent. We know that's going to be 3x squared plus 2ax plus b, and the constant to be equivalent to 0. So we were told that at x is equal to 1. Hey, so let's substitute our x value to be equal to 1. So the f prime of let me just write this so that you see that at x is equal to 1, we know that the gradient of the tangent is equal to -8. We know that they have given that at x is equal to 1, which means if on the function on our function at x is equal to 1, the gradient is equal to -8. Let me just do this. So let's start by substituting the x value of the where the tangent and the graph, our polynomial graph, will be able to intersect. So we're gonna have 3 times 1 all squared plus 2a times 1 plus b. So we're gonna have f prime of 1 to be equal to 3 plus 2a plus b, and we know that the gradient of the tangent is equivalent to f prime of 1. So what are we gonna do? So we're gonna have 3 plus 2a plus b, which is equal to -8. Then after that, you end up having 2a plus b, which is equal to -11. So that will be our equation 1. So now let's determine our equation 2 now. How are we going to do that? So we are told that at x is equal to 1. So let's determine the y value of at x equal to 1. So we will need to determine f of 1. So f of 1 will be 1 cubed plus a 1 squared plus b times 1 plus 18. Then f of 1 f of 1 now we see that that's the y value, guys. Please don't forget that. Let's don't use f of 1, let's just use g of x, since we know everything about g of x. G of x is equal to -8x plus 20. So let's determine g of 1. G of 1 is -8 times 1 plus 20, then we end up having 12. So now that will be easy, guys. How is that easy? Because we know that g of 1 is equal to 12, and we also know that which means otherwise this means that the point of intersection of the tangent and the graph will be 1:12. So substituting this point on the function of f, we're gonna have 12, which is equal to 1 cubed plus a times 1 squared plus b times 1 plus 18. So we have 12 equal to 1 plus a plus b plus 18. Then we end up having a plus b, which is equivalent to -7. This is going to be our equation 2. So our a can be equal to -7 minus b, which is equation 3, Then we can now substitute equation. We can substitute equation 3 into 1. So when we substitute equation 3, we're going to have 2. Then wherever we see A, we substitute by negative 7 minus B equal to negative 11. Then we solve it. It's negative 14 minus 2B is equal to negative 11. Then after that, we have negative 14 plus 11. Then we end up having negative 2. Oh, we have 2b here. Yes, then 11 minus 4a, is it 2b? Let's check that so that we don't have any error. Okay, let's just say let's just fix this one so that we have our equation 1 to be in this way. We had 2a plus b equal to negative 11. So our b will be equal to negative 11 plus, no, minus 2a. Then it can be 1. Let's just change our equations, making b only the subject of the formula. So b here is going to negative 7 minus a. Then that's equal to 2. Then we can say 1 is equal to 2. How is it 1 equal to 2? Because negative 11 minus 2a is equal to, what is our equation 2? Our equation 2, it's negative 7 minus a. Then now we can solve. We have negative 2a plus a equal to negative 7 plus 11. Then we have negative a is equal to positive 3. Then we divide by negative 1. Then we end up having a to be equal to negative 3. Is it a? See something. Negative 7 minus a. Yes. Then our b will be equal to, negative 7 minus 3. Then we have negative 4. Then that will be our values. Okay, we are done with that. Let me repeat it again so that you can understand. So initially we are given that f of x is equal to x cubed plus ax squared plus bx plus 18. So they told us they were given us the equation of the tangent. So we started by determining f prime of x, because we say that f prime of x, or the first derivative at that specific x coordinate of x, it is equivalent to the gradient of the tangent. So after that, we determined and we find that it's 3x squared plus 2ax plus b. Then after that, we substituted x equal to 1 because the specific x coordinate of the point of intersection of the tangent and our polynomial, our graph, is 1. So we substituted that. Then we ended up having 3 plus 2a plus b. Then after that, we equated because the f first derivative is equal to the gradient of the tangent. Then we ended up having f prime of 1 equal to the tangent, gradient of the tangent. Then we have our equation 1 to be b equal to negative 11 minus 2a. We just made b the subject of the formula. It was negative 11 minus 2a. That was our equation 1. Then now we determine first the y coordinate of the point of intersection of the tangent and the function which we have, function of f of x. So this is, let's just say this is the point where they will intersect. Then we find out it's 1:12. Then after that, we substituted this point in our function f of x. Then we ended up having 12, 1 cubed plus a, 1 squared plus b, 1 plus 8. And then we have a plus b is equivalent to negative 7. Then after that, I made b to be the subject of the formula. Then it was negative 7 minus 8. Then after that, equation 1 is equal to equation 2. Then we solve that by saying negative 11 minus 2a is equivalent to negative 7 minus b. Then negative 2a plus a, this is negative a, we know that, which is equivalent to then negative 7 plus 11. 7 plus 11. Sorry, it's 4 here. Sorry. Did maths error. It's 4. 4. So here we were supposed to subtract by 4. Then you have negative 3. So therefore, our A it's negative 4 and our B it's negative 3. Sorry for that mistake, that typo. Because negative 7 plus 11 is positive 4. Then you divide both sides by negative 1. Then you end up having negative 4. Then you substitute the value of negative 4 in the original equation, equation 3. No, in equation 3, then you end up having negative 3. So then therefore we have A is equal to negative 4 and B is equal to negative 3. Okay, now let's check our question 9. Question 9. Let's check question 9. Okay, on question 9, let's try to be fast. Calculate the x-coordinates of the stationary points of F. We know that for the stationary points of F, we know that we just, what's 9.1? The stationary points, we know that F prime of X must be equal to 0. So you can just write this, okay. Stationary points at F prime of X equal to 0. So at stationary points, F prime of X is equal to 0. At stationary points, F prime of X is equal to 0. So since we are given F prime there, so we're just going to write 3x squared plus 8x minus 3 is equal to 0. Then we look for the factors, or you can use the quadratic equation. So we know that it's, if you use the factors, you're going to have x plus 3 and 3x minus 1 equal to 0. Then we're going to have x is equal to 1 over 3, or x will be equal to negative 3. This is our stationary x coordinates. Okay. Now moving to 9.2. For which values of x is f concave down? F will concave down if the second derivative is less than 0, guys. Okay, so let's write that down. That f concave down if f prime of x, the second derivative of f of x is less than 0. That's when it can concave down. So let's determine f prime of second derivative now. So the first derivative of x, we are given that it is 3x squared minus 8x minus 3. So the second derivative of x will be 6x minus 8. Then now that's when you have to write this small English, that f concave down at f prime of x equal to, less than 0. That's when it's concave down. So we can just have 6x plus 8 6x plus 8 less than 0, then 6x less than negative 8, then divide by 6, then our x must be less than negative 4 over 3. So it will concave down when x is less than negative 4 over 3. That's when it will concave down. Okay. 9.3. Determine the values of x for which f is strictly, underline that term, it is strictly increasing. Strictly increasing. So f will be strictly increasing where will it strictly increase? It will strictly increase when f prime of x is greater or equal to 0. So since we have already calculated the f prime of x, the stationary points, which are these 2 points, so now we can determine now, and we can just automatically, we can even write this so that we can know the solution. We have -3 and 1/3. Let's see where the solution is found. When we substitute by 0, are we going to get a number which is greater than 0? Let's come and check. 0, 0. -3 is not greater than 0. So the values will be found here outside. So basically x must be less than or equal to -3, or x must be greater or equal to 1/3. So all these values which are greater or equal to 1/3, the function will be strictly increasing. And when it's less or equal to -3, the function is strictly increasing. So this is also, guys, the same as from -infinity to -3. But check, it's an including bracket. Union, which is or, from 1/3 to infinity. So those are the two solutions of our answers that side. Now let's solve 9.4 now. The last question of the day. The last question of the day, 9.4. Okay, on 9.4, we have, if it is further given that f of x, okay, let's write it, f of x is equal to ax cubed plus bx squared plus cx plus d, and f of 0 is equal to -18. Determine the equation of f. Okay, let's determine the equation of f. We are given that f of 0 is -18. So let's come and substitute 0 wherever we see 0. F of 0 is equal to a times 0 cubed plus b times 0 squared plus c times 0 plus d. This is said to be equal to -18. So we can see that our d automatically is equal to -18, guys. So we now have our d. So basically now our f of x is now ax cubed plus bx plus cx minus 18. Now let's determine now the value of a. Let's start by, because we know that initially we were given f prime of x, the first derivative, to be 3x squared plus 8x minus 3. So now let's determine the f prime of x of this. So the f prime of x will be equal to 3ax squared plus b, plus 2bx plus c. So now since that, let me just write this, since f prime of x is equal to 3x squared minus plus 8x, sorry, minus 3. So we know that we can just see that 3a is equal to 3, because 3x squared and 3a x squared, please, they both have the same x squared and x squared, so they have same variable, so they have x squared and x squared, so we just equate them. Then we can just then say then our a will be equal to 1, because divide by 3, we get our a to be equivalent to 1. So at least now we have our 1. And also 2b and 8, they have the same, so we equate them as well. So we have 2b is equal to 8. So we solve for b, and then our b will be equal to 4. So we have our a to be equal to 1 and our b is to 4. Okay, so since we have the value of a to be 1 and b to be 4, we now need the value of c. How can we find the value of c now? So we can find the value of c by substituting into the equation. Now we can substitute in and get the value of c. We can get our value of c, guys. So how can we find the value of C now? We know A, we know B, we only left with C now only. How can we get C? Because our C, we have to calculate our value of C. So our value of C is easy like that. Our C will be got -3. You see that? Our C will be got -3. So then, therefore, the equation of f of x, the original function, will be equal to x cubed plus 4x squared plus, no, it's not plus z, it's minus 3x minus 18. So this will be our function. So we have f of x is equal to x cubed plus 4x squared minus 3x minus 18. So let me restart again. So on this question, we start by looking for, we are given f of x to be ax cubed plus bx squared plus ax plus d. Then they told that f of 0 is equal to -18. So since f of 0 is equal to -18, we know that f of 0, that's a y-intercept. So everything will be 0, 0, 0. Then we left our d to be equivalent to -18. Then now we determined the first derivative of our function f of x, since we already told that we have our function f of x, which is 3x squared plus 8x minus 3. Then now we determined this, and we had 3ax squared plus 2bx plus c. So since these are our two derivatives, I even wrote here, since our the derivative, the original answer derivative, which we have, is 3x squared plus 8x minus 3. So we just equated them. So let me just write something here so that maybe you can see this. So basically, we are saying that we are told that f prime of x is 3x squared plus 8x minus 3. And we also calculated that f prime of x is 3ax squared plus 2bx plus c. Let me see. Yes, plus c. So if we equate these two, we're going to end up having 3x squared plus 8x minus 3 equal to 3ax squared plus 2bx plus c. So this one and this one, they're same. So we're just going to equate them because they are all the same. Then this one and this one, they are the same. 8x is equal to 2bx. And also this one and this one are the same. -3 is equal to c. So we can see that this one and this one will cancel each other. X and x will cancel each other. Then we are left with 3 is equal to 3a. And we are left with a is equal to 2b. Divide by 2, divide by 2. Divide by 3, divide by 3. Then we end up having our a to be equal to 1. And our b is equal to 4. So that's how we do that question number 9.4. Then question number 10 is for maximizing. We'll do this one on another day. So for today we are done, but we can let's just do question 10 because it also have calculus. Let's just do question 10 so that we know that we are done with calculus. Question 10. Okay, let's do it fast. The number of molecules of a certain drug in the bloodstream T hours after it has been taken is represented by the equation m of t is equivalent to -t cubed plus 3t squared plus 72t, and giving the interval 0 to 10. Okay, determine the number of molecules of the drug in the bloodstream 3 hours after the drug was taken. This is easy. 3 hours after the drug was taken. So 10.1, since we are given m of t to be got -t cubed plus 3t squared plus 72t. Then 3 hours after the drug was taken, so they've already given us the time, which is the 3 hours. So we just have to substitute. Then we end up having our -9, -27 plus. Then you just use your calculator here. Then after that, after you're done using your calculator, it's gonna be 216 molecules. So you are done with 10.1. Then let's move to 10.2. So this is how you do it. So 10.2, they said on 10.2, determine the rate at which, the moment you add the rate, which means they need the first derivative. Determine the rate at which, which means they need this first derivative. Okay, the rate at which velocity, acceleration is the rate at which so the rate, which means we are now determining the first derivative. Okay, so what's going to happen this time is that we have to determine the first derivative of m of t, which is equal to negative t cubed plus 3t squared plus 72t. So m prime of t, which is the derivative, will be equal to negative 3t squared plus 6t plus 72. So now they highlighted that in the bloodstream is changing at exactly 2 hours. So we need now the rate at 2 hours. So negative 3 times 2 all squared plus 6 times 2 plus 72. Using our calculator, 2 squared it's 4, 4 times negative 3 it's negative 12, negative 12 plus 12 it's 0, then plus 72 we have 72. So this is the answer which we need. So you can write with the surname, which is 72 molecules per hour. Okay, now let's do the last one, 10.3. 10.3, they're saying how many hours after taking the drug will the rate at which the number of molecules of the drug in the bloodstream is changing be maximum? So the moment you hear B maximum, which means we have to calculate the second derivative. So since we know that the first derivative is gonna be negative 3t squared plus 6t plus 72, now we only have to determine the second derivative of t so that we can certify the moment you have maximum and the how many hours after taking the drug will the rate. So we need the rate of the first derivative. So the first derivative now will lead us to calculating the second derivative. So the second derivative here is going to be negative 16 plus 6. Okay, so now we know that at maximum the second derivative must be equal to 0. So we have negative 60 plus 6 equal to 0. Then negative 60 is equal to negative 6 divided by negative 6. Then our t is equal to 1. So therefore the maximum rate of change of the number of molecules of the drug in the bloodstream is after 1 hour. So the value which we need is 1 hour. So thank you so much for tuning in for today. It was so amazing. It was so great. We were doing calculus today. We started by saying and having an overview of the first principles. We also had the power rule, and we were able to do everything. Please, if you have more questions on this section, please do ask so that we can assist you. Till we meet next time, have a blessed evening and may God embrace you. Thank you.